Next up, we have Sanjuna Matthews from Accenture speaking about Roboverse developing a virtual ROS2 robotics ecosystem for enhanced testing and validation.
Hello, good afternoon all. I am Sanjuna Mariam Mathews, team lead of Robotics division at a reputed global IT firm. But today I am here as the author of a book, Roboverse, ROS2 and Beyond, co-authored by Harikrishnan K, who was my colleague. And this is our book. So this book delves into advanced robotics topics, including integration with NVIDIA Omniverse, Isaacsim, Unity, etc. So in this session, I will be discussing on how seamlessly we can connect NVIDIA Omniverse with ROS2 framework. So today, I will be taking you to a journey through virtual ROS2 robotics ecosystem for enhanced testing and validation, leveraging the power of NVIDIA Omniverse. Before diving deep into the topic, I would like to tell about my career in robotics. I have started my journey in robotics as a postgraduate student in robotics and automation from College of Engineering, Trivandrum. And by the end of my master's course, I have led a team for the implementation of COVID service robot at Medical College Hospital, Trivandrum, and deployed the same. It was well accepted by the hospital and was used there for food and medicine delivery for a time. After that, I started getting inquiries from students on different robotics projects. Then I understood the need for a proper reference for ROS and ROS2 framework. So I have started a YouTube channel for the same to share my knowledge and experience in different projects and also to share the tutorials on the most interesting topics in robotics. After that, I started getting opportunities from IEEE RAS Kerala chapter as a speaker. So always my goal is to train students who are struggling to start a project in robotics. So as we discussed yesterday, when a student tries to do a project in robotics, the particular student will be struggling so much to start. So my book will also deal with the same topic, like from beginning to advanced topic, how to deal with different tools and how to implement a use case end to end. So after creating YouTube channel in 2020, I have done an internship in a multinational company and then got the opportunity to work in 2 other multinational companies as a robotics engineer. So at this point, I wanted to share my knowledge and experience which I have gained in all the 6 years through my book. So we have launched our book last month, Roboverse, ROS2 and Beyond, and it's now available in Amazon. So if you want to check out also, I have a copy in my hand, you can come and see. So in this talk also, I will be including some of the insights from our new book. So it starts from robot operating system framework, including all the hands-on experience, hands-on examples on Move It, navigation stack, etc. And then I hope it will help for the people who want to migrate to ROS2 also, since it also, those session also covers the most important topic in robot operating system framework, ROS2. And we also have the other topic as well that a robotics engineer need in his career. So modeling a robot using a CAD software is also an important aspect. So as a robotic engineer, we have to get exposure in different areas. Like it's not like programming or designing or setting up hardware. We have to gain skills in different areas. So 3D modeling in SolidWorks also described in one of the chapters. Then another important factor is the orchestrator platform. Orchestrator platform is important to orchestrate different tasks of a robot. So we have sessions on that. Then comes the topics, advanced robotics topics like integrating with other platforms like NVIDIA Omniverse, ISAC Unity, and also ChatGPT, user interface, etc. So imagine a robotics team is trying to develop an autonomous delivery robot. They may be facing many challenges. If they want to proceed directly with the hardware setup, they will face many challenges. There will be limitation in the testing and optimization of algorithms in real-world environments, and also the cost for testing algorithms in a physical prototype will be high. There is a risk for damage. And while optimizing and testing algorithms in physical hardware, it is difficult to predict the fail scenarios also. We need to arrange the real world accordingly to handle all the different scenarios, handle all different configurations for different throughputs. We need to set up the robot and environment accordingly. So it will cause some cost and also time. So that's why we are going ahead with simulation before proceeding to actual hardware. So Omniverse is a real-time 3D simulation platform for designing, simulating, and optimizing virtual environments and robotic systems. So this is one of the tools which can be useful for simulation in realistic testing environments. As you can see in the pictures, it has high realistic environments. It has a photorealistic environment, and it can accurately depict the real-world objects and characteristics. And it have dynamic lighting and advanced physics, which help it for the photorealistic capability. So it will lead to a very good impact in development because of its performance metrics, and also we will be able to make the iterations faster. So why we cannot go with the traditional simulation methods? Why we need to go ahead with ISAC. ISAC is the toolkit in NVIDIA Omniverse for robotic simulation and synthetic data generation. So comparing with the traditional simulation methods, in ISAC there are so many advantages. First one, as I already told, the photorealistic rendering, where traditional simulation methods rendering is very basic, and physics will be also very basic. So in ISAC there is advanced physics which help us to simulate in a very realistic way, and it can be accelerated. It have a good performance because of GPU accelerated performance, and it is very easy to integrate with AI and ML models. And consider the scenario, if one of the team members who is doing a simulation is working remotely, if that particular person is not at the place where we are doing the project. So in that case also, ISAC will help to do a collaborative development. There is a tool in ISAC which helps to store the files across and also to use the files. Like if one person is making one change at one place, the other person will be able to get all the changes seamlessly. And also there are options like live sessions which also help in the live collaboration. And we can consider another thing. When we are going ahead with traditional tools, everything was disconnected. There will be a particular tool for 3D modeling, another tool for simulation, another tool for collaboration. So in NVIDIA ISAC or in NVIDIA Omniverse, we have it connected. We have a single collaborative environment for many applications. So we can do the pipeline using NVIDIA Omniverse itself. We don't need to convert files in between and then use it Instead, we can use the platform and do a collaborative workflow. So let's discuss more about virtual ROS2 robotic ecosystem. Basically, it can simulate and also it can act as a digital twin of a robot. So it will help us to have some features like real-world XR integration, predictive maintenance, performance optimization, training and simulation. So with Omniverse, we will be able to collaborate and also integrate ROS2 with Omniverse using a ROS2 bridge. Consider the scenario, a client wants to do a project. He needs a autonomous robotic solution for a shopping assistant robot. So in that case, if the client is asking for another request, like if he wants to see it in an XR setup before deploying the hardware. Otherwise, there will be cost involved, like they need to purchase robots, they need to set up the real world environment, and then if the solution does not work, and if the solution does not meet his expectations, it will be a problem. So the client wants a XR solution first. Once he is satisfied and if he is able to experience the solution that we have done, he wants to proceed. In that case, ISAC SIM will help to do an end-to-end solution. ISAC is Intelligent Simulation and Control, which is the full form of ISAC. So what will be the first step? We need to create the robot first. Then we need to create the real-world environment around. And third step will be to train the robots. Fourth step will be to deploy the application in a XR device. Then once the solution is working, we will deploy it to physical hardware. So this is a proposed high-level architecture for that. NVIDIA Omniverse will help to connect with CAD tools like SolidWorks or Maya. So we will be modeling a particular environment in some extension, like SolidWorks, it will be SLD ASM. So in that case, we need to get it as a generic format where we can do our simulation and digital twin implementation also. So NVIDIA Omniverse, there is a universal language for the exchange of 3D data, that is USD, Universal Scene Descriptor. So in Omniverse, we have extensions to convert the files from other CAD tools to the required one, to the USD files. So we can do our programming inside, we can add animations, we can simulate it, or we can add the functionality for digital twin, and we can keep it as a SIM-ready model. This SIM-ready model, we can use like standalone components, we can use it. So for the scenario that we have considered, shopping assistant robot, we need to model robot and virtual environment, and then by the conversions available in Omniverse, we can convert it to USD file. This can be done in an automated way or manual way. And we have a central repository which can store different files, like different standalone components. So these assets will be of different types. One USD can include animation, one USD can include just the geometry, another USD will be for textures, and we can create a main USD having all these sublayers. So it will preserve all the hierarchy that we got from the CAD tools, also the materials and other features as well. So using ISAC SIM, we will be able to simulate the robot. Like we can import URDF directly and work on it, or we can take the model from the CAD tools. Then we can add joints. If it is a URDF, joints will be already defined. So what will be the next part? We need to train the robots. Only if we train the robots, we will be able to make it work like a shopping assistant robot. So for training, we can use a tool called Replicator, which can generate synthetic data for training. So if we are considering a object, that particular object can be spawned in different ways, like with different textures at different positions and different rotation in a fitted environment. So using Replicator, we will be able to generate tons of data set which can be used for training. Once the model is trained, we can simulate the robot in NVIDIA Omniverse Isaacsim world itself, and if it is fine, we can directly deploy it to a extended reality. So we can deploy it to workstations, web browser, virtual reality, or augmented reality. So the client will get the experience to feel the environment. Client will be able to step into the environment and see how the robot is working in the virtual environment. So the simulation part is done. After simulation, we are deploying to XR device. So the client is satisfied with the solution, with the autonomous robotic shopping assistant solution. If the requirements are met, we can make the model that we have created in Isaacsim as a digital twin. So previously in simulation also, ROS2 will be controlling the robot in Isaacsim environment. We can modify the scripting to make it a digital twin, like once the simulation part is done. So in that case, in ROS2 framework, it will be connected to physical layout. Since ROS2 framework is connected to Isaacsim via ROS2 bridge, Omniverse will be able to publish and subscribe different topics. So if it is a digital twin, we can get the live join states in Isaacsim. So you can see in the ROS2 side, we have a robot, real robot. In the other side, we have a virtual robot. So that basically that's the virtual replica. So it is called digital twin. So from real robot, we can publish join states and send to digital twin. In the digital twin side, it will subscribe join states from Omniverse. So it will publish join states to the real robot, so that the real robot will also have a knowledge on what's happening in the digital twin. So consider this action graph. Action graph is basically a visual scripting interface. On every tick, it will publish a join state. So we can give the transform of the robotic arm or whatever in ROS2 publish join state. So it will start publishing join state of the particular robot. Similarly, at the same time, on each frame of the playback, it have to subscribe join states from the real robot also. So we can configure ROS2 topic in ROS2 subscribe. Let it be join state. So we can give the topic name as join state, so it will subscribe. Then we can connect it to articulation controller, which will make the motion in the virtual robot. So you can see in the picture, first picture is the digital twin of a real robot. So the transform of the real robot is shown in the picture on the right side. So that particular join state is sent to the digital twin of the robot. So it will receive it and then behave the same. It will be a replica of the real robot. Similarly, it can also publish it to ROS2 framework. We can get it as a topic and visualize the data. So this was the case of digital twin. So how we will implement the simulation in Isaacsim. So this is an example scenario. So in Gazebo, we have done teleoperation and control the robot via CMD-well, which is the velocity command. Same scenario, we have a subscriber for twist. We can configure the topic name there. So in velocity, in CMD well twist topic, we have two components, linear velocity and angular velocity. So both of them will be vectors and we need to split it to three. So we need to take linear velocity dot x and angular velocity to dot z. We can break the vector and take the required values as angular velocity and linear velocity of differential controller. So this will take the velocity of mobile robot and convert it to joint velocities. Then the articulation controller will convert the joint velocity to individual joint state which can control the mobile robot. So if we are integrating navigation stack also, the same will be subscribing twist, and we may need to also send the laser scan information to make the navigation stack work. So these are also other scenarios. So if we want to stream a camera visual from Omniverse world, we need to create a render product first and then connect with ROS2 camera helper. So ROS2 context will make the synchronization and the compatibility possible. So in ROS2 framework side, we will be able to get the camera topic. So we can visualize in RVS. Similarly, we can also integrate move it simulation also. We need to do program like this. We need to subscribe to the joint state and publish a joint state, which is basically the feedback. And then subscribe joint state, we need to connect to articulation controller. But we need to make one change at the ROS2 framework side. That is, we need to make it a topic system. Instead of the available hardware, we need to make it topic subscribe system. So it will, the particular joint states that is coming from the ROS2 framework will command the robot in the ISAXIM and make it work. So you can see the RVS side and the simulation side, which is in ISAXIM. So that's it for today. In summary, we can integrate Omniverse with ROS2 framework seamlessly. It will enhance the workflow and it will scale the simulation, and also it will be very helpful for realistic testing scenarios. So it will be an end-to-end solution. Like we can give the models to nuclear server where it will be saved, stored, and then we can do all the simulation inside the USD files. We can train the models, and once it is trained, we can deploy. So this is the end-to-end flow. Thank you. If you have any questions, you can ask now.